Hey, what's going on, everybody? This is JJ, and today we're going to do some very basic rocket science. And so there's an interesting relationship in physics where if you know the position of an object as a function of time, you could find the derivative of that and identify the velocity of that object as a function of time. And then furthermore, you could take the second derivative of that and find the acceleration of that object along one dimension. And so the interesting relationship arises where we can then go in the other direction. We can find the antiderivative of the acceleration of an object with respect to time and find its velocity, also known as, we could also call this integrating or integration. And so we can integrate the velocity of an object, if we know it, as a function of time to find that object's position. And so the question is, what is the height of the rocket above the surface at 10 seconds? And the only information we are given is its acceleration as a function of time. So what we can do is we can take this function and integrate it. And so our velocity in the y dimension, or along the y dimension, will be equal to the velocity at time 0, so our initial velocity, plus the integral from 0 to t of this function of our acceleration. You know what, I'll write that actually, of our acceleration, so a y. And so vy is equal to, this becomes 0, so really it's just our initial velocity was 0, from 0 to t of 2.8 t. And so vy, our velocity along the y dimension means up and down, because rockets move up and down, generally speaking, unless it's a ballistic missile or a cruise missile where it's running horizontally. But in our case, it's just starting at rest and moving upwards. And so we want to know what happens, how high it is after 10 seconds. We want to know its position after 10 seconds from liftoff. And so the antiderivative of 2.8 t from 0 to t is going to be, we take this t and we add 1 to its power and then divide by n plus 1. And so we get 2.8 t squared, so t1 plus 1 is 2, and divide that by 2. And then we could say plus c if we were being mathematically precise. So we have our velocity function now as a function of time, our velocity, and along the y dimension. And so we could take this and find the integral, we can integrate it to find the position, because we don't want to know the velocity. We want to know the height after 10 seconds, not its velocity after 10 seconds. So the position along the y dimension will be equal to the initial position plus the integral from 0 to t of our velocity as a function of time. And so I could add dt here, by the way. And we can come up here. And so the position will be equal to, again, x, the initial position is 0, so we don't have to worry about it. So we really just want to integrate from 0 to t of 2.8 divided by 2 t squared dt. And so the integral of this, again, we just apply the same rule. We do n plus 1, so 2 plus 1 divided by 2 plus 1, which is 3. So the position will be equal to 2.8 divided by 2 divided by 3 times t cubed plus c. And so now that we know our position formula, we can plug in our 10 seconds into t and get our position after 10 seconds. So that will be equal to, this is 1.4 divided by 3. T is going to be 10 seconds, and we're going to cube that. And so we get, let me plug it into the calculator. So this is equal to 467 meters. So 10 cubed is 1,000 multiplied by, this came out to be 0.466, repeating, and then 7. And then we multiply them together to get 467 meters above the surface. So that is the answer to question number 1 here. Question number 2 is, what is the speed of the rocket when it is 325 meters above the surface? So in this case, let's use a different color. We want to know its speed given a position. So our position here, our xy, so our x along the y dimension is 325 meters, and that is going to be equal to, we could say, 1.4 over 3 times t cubed. And so we can divide by both sides by 1.4 over 3. Divide this by 1.4 over 3. And so we get 325 divided by this. I don't know what that is. Let's use a calculator. It is roughly 696.4. We'll use one significant digit, I guess. I think we can call it. And that is equal to t cubed. And so we can cube root both sides. And we get t to be equal to, if I plug into the calculator, we get roughly 8.9 seconds. So at 8.9 seconds, the position of the rocket is 325 meters. So we could take this 8.9 seconds and plug it into our velocity formula. And so the velocity, our speed, is going to be equal to 2.8 divided by 2 is 1.4 times 8.9 seconds squared. And this is going to be equal to 8.9 squared that is roughly 110 meters per second if we round. And so that is our answer to question number 2. The speed of the rocket is 110 meters per second. And so that is very basic rocket science. We use the integration technique of an object that has a varying acceleration. If there was constant acceleration, we would use kinematic formulas. But in this case, the acceleration is a function of time that varies. And so we could use our integration technique to find the various answers to these questions. And with that, we'll see you in the next video.